So today we're going to introduce our next topic, which is data management and data manipulation. And the two libraries that we will focus on are pandas and numpy. We'll focus on numpy today. And just a reminder that there are many other libraries that can be used for these kinds of tasks. These are just some of the most popular ones. But if you needed to do something that involved, say, spatial data, there's one specifically for maps that you could look up. So in general, a good practice is to look up a library for whatever task you're trying to do, and you'll get a number of suggestions. But for the most part, especially pandas will come up over and over and over again. And that's going to be our main topic on Thursday, our next class. Today we'll focus on numpy, which is kind of like I'd say sort of a view of the essential functions and attributes of the pandas library. So we'll see that they're very much analogous, but pandas is a little more powerful and has more tools we can use. So here we have some resources, documentation, other things that come up throughout our lesson, and then this edX analytics class in Python. This is a great open source course where I referenced that quite a bit to inspire this lesson today. So, digging into NumPy, it's helpful to think about spreadsheets, and I'm sure you're all familiar with what a data set looks like in an Excel spreadsheet, for example. You have a series of columns and a series of rows, and you know the columns usually represent some kind of variable, and then the rows represent different records. You know, if you had customers in Amazon, you might have how much they bought in the column, in one column, how many times they were on the site in another column, whatever things Amazon wants to track about their customers, but then each row would be a different record, which would be a different customer. So essentially we see that same data structure come up over and over and over again. Another data structure we see is series data, and you'll see this especially in financial applications where you're monitoring the price of something over time, a stock price, GDP, exchange rates, things like that. So we'll look at both series data and data frames. So in other words, a one-dimensional array kind of looks like a series, and then two-dimensional array looks more like a spreadsheet with multiple variables and records. Okay, so let's just get right into it. First thing we need to do is import the NumPy library, and the way we do that is typically like this, and that's just by convention. That's just what people do. Okay, good, that ran this time. Next we have creating a basic array. So here we're going to create a one-dimensional array with just these 6 numbers. We're going to print it, and then we're going to print its type. Okay, so we print the array. It doesn't look much different from what we specified, but there are no commas in between, so that's kind of a difference in the appearance between this and a list. And notice that the class references the NumPy library. So this is something that is, because we use the function from the NumPy library, we've essentially created a data type that exists within the NumPy library. So ND array, n-dimensional array, I'm not sure what the ND stands for. Okay, so once we have an array, here we're creating another array, x equals, we're storing it as x equals np array. And notice I'm entering numbers that are not integers this time, these are floats. And I'm specifying the data type here, so this is a second argument that I can use in the array function. And that's really useful when we need to, which we'll do later, import a data set, and we want to specify the type of that data while we're importing it. So say all of the values are represented as strings if it's coming from some kind of HTML. Right in one step, we can import the data and then convert it to a float or an integer or whatever we want. So we have our array here. It was specified as float data type. I can do several operations with that data. So because this is a numpy object, I can use functions, more functions within the numpy library, sum, mean, and standard deviation. So these are, we're doing x dot and then the function. So I'm applying this function to a numpy object. So all of these will work. The /n or backslash n is something we haven't talked about, but I'm sure you've run across it. It just allows us to specify how we would like to separate, and it just means a new line. So actually in this case, we're deciding that we want to separate the output by each one on a new line. So that /n just has to do with customizing the way our output looks. It's not adding functionality here. We would still get the same numbers, but they would all be in a single line if we didn't have that piece there. Okay, next thing to go over is multi-dimensional arrays. A multi-dimensional array has several rows and columns, and notice here we're specifying the data. We're not making it an array yet, but we're going to down here. So my variable y is storing this data. Let's see what it looks like before I make it into an array. Okay, so it looks like a list, right? It's just a list of 3 lists. And each of those lists has 6 numbers in it. So to make it into an array in the NumPy context, I can say AY for array AY is np array, np.array, and then here I'm inputting that data. So this is just another way to do it, specifying the data outside of the array and then coercing it into the array data structure. And my second argument is the data type that I'd like to use. So I'm doing 3 different, creating 3 different data structures. The first one is all integers, the second one's all strings, and then the third one is all floats. And I can run this and see what that all looks like. Okay, so those are now strings. And then these are floats. See, we have a dot and then nothing after it because they don't have any fractional component for these numbers. But this specification of the data type would allow for a fractional component. Okay, indexing. We need to know how we can access information within an array. This I don't think should be here. Let's see, why did I put that there? I think I just miscategorized this. So I'm showing that I can do the same operations that I did for a one-dimensional array, but I can do them in a multi-dimensional array. So it's just going to put all of these numbers into the sum, mean, and standard deviation functions. So what I really want to talk about is how to index the values in the array. So here's some examples. I can access the first entry by its row and column separated by a comma. So we know that we're used to this kind of, but we've only seen it with single, we've seen it with lists, almost exclusively lists. So I'll just comment this part out and look at the first item in the array. It's going to be a 1, okay? And then the last entry we could specify as the last row and the last column. That's probably the most efficient way to do that. I can also access the first row in 2 different ways. So let me again just do one at a time. So here I can get the first row Another way we sometimes see this is we'll say for the first row, get all of the columns. So I kind of think of the colon as saying get every column from this first row, and it gives me the same thing. So we can use both. And analogously, we can do for the first column, right? Comma 0 says the first column, get me every row. So that's what the colon indicates for us. So that's giving me the 1, 7, and 13. Okay, so I think we'll stop this video here. That's a pretty good introduction to working with arrays, and then we'll do another video to cover the rest.